We need to put a gesture in our app just to show how to do it, and we need to learn how gestures work. People use their fingers rather than a mouse to select and manipulate objects on the iPhone screen. The moves that do the work, are called gestures, give the user a heightened sense of control and intimacy with the device. And there are several standard gestures available for you to use in your app. And what the frameworks provide is a gesture recognizer that tracks the action of the user's fingers. Now, the standard gestures are tap to press or select something, like a single mouse click, or drag, scroll, or pan, move side to side, as you would do in, say, Google Earth. You can flick or scroll and pan quickly, which is what you do a lot of times in lists. And you can swipe, which is like a flick, but in a table view row, such as swiping in a table to reveal the delete button. You can also double tap to zoom in and display a block of content or an image in the center, or to zoom out if you've already zoomed in. You use a pinch to zoom out and an unpinch to zoom in. Now, a pinch is actually a pinch close, and an unpinch is a pinch open. And you use touch and hold, also known as the long touch, to show a magnified view of editable text for cursor positioning. And you can use it for other things. Now, the UI Gesture Recognizer class defines a set of common behaviors. It can communicate with its delegate, an object that adopts the UI Gesture Recognizer delegate protocol. In other words, if you want to offer a finer grain of control over what happens when fingers touch the display, you can use a delegate of the UI Gesture Recognizer class that recognizes gestures and customizes their actions. With a Gesture Recognizer object, you can separate the logic for recognizing a gesture from the action that should occur. When one of these objects recognizes a common gesture, or in some cases a change in the gesture, it sends an action message to each of the designated target objects. These are the concrete subclasses of UI Gesture Recognizer, starting with UI Tap Gesture Recognizer, which looks for a single or multiple taps. For the gesture to be recognized, the specified number of fingers must tap the view a specified number of times, and you set the number of taps required property to the number of taps for the gesture to be recognized, and you set the number of touches required property to set the number of fingers required to tap for the gesture to be recognized. Taps are what they call discrete gestures, which means the associated action message is sent only once per gesture. Action methods handling this gesture may get the location of the gesture as a whole by calling the UI Gesture Recognizer method location in view. And if there are multiple taps, this location is the first tap. If there are multiple finger touches, this location is the centroid of all fingers tapping the view at the same time. And you can also get the location of particular finger touches in the tap by calling the location of touch in view method. If multiple taps are allowed, this location is that of the first tap. So this UI Tap Gesture Recognizer is very sophisticated, and you can simply use its methods rather than creating a delegate unless you want to get a bit finer control over what's going on with the tap. The UI Swipe Gesture Recognizer looks for swiping gestures in one or more directions. Now, a swipe is also a discrete gesture, so the associated action message is sent only once per gesture. Now, it recognizes a swipe when the specified number of touches, which is the number of touches required property, is moved mostly in an allowable direction, which is in the direction property. It has to have moved far enough to be considered a swipe. Swipes can be slow or fast. Now, a slow swipe requires high directional precision, but a small distance. A fast swipe requires low directional precision, but a large distance. You can determine a location where a swipe began by calling the method location in view in the UI Gesture Recognizer, which, if there's more than one finger touching, gives you the centroid involved in the gesture, and then you can call location of touch in view method, which gives you the location of a particular finger touch. The UI Pan Gesture Recognizer looks for panning or dragging gestures. User has to be pressing one or more fingers on a view while they can pan. Now, your subclass could implement the action method for this gesture recognizer and can ask it for the current translation and the velocity of the gesture. Now, a panning gesture is continuous. It begins, and the UI gesture recognizer state began constant is set, when the minimum number of fingers allowed, which is in the property minimum number of touches, when that minimum number of fingers is moved enough to be considered a pan. It changes, and the UI gesture recognizer state changed constant is set when a finger moves while at least the minimum number of fingers are pressed down at the same time. The panning gesture ends, and the UI gesture recognizer state ended constant is set when all fingers are lifted. Now, what your subclass of this class can do in action methods is query the UI pan gesture recognizer object for the current translation of the gesture using the method translation in view, and also the velocity of the translation using the method velocity in view. You can specify the view whose coordinate system should be used for the translation and velocity values. Your subclass can also reset the translation to a desired value. The UI pinch gesture recognizer looks for pinching gestures involving two touches. When the user moves the two fingers toward each other, the conventional meaning is zoom out. And when the user moves the two fingers away from each other, the conventional meaning is zoom in. So moving two fingers toward each other, which is your typical pinch or pinch close, that's a zoom out. And moving the two fingers away from each other, which is an unpinch or pinch open, that's a zoom in. Pinching is a continuous gesture. The gesture begins with the constant UI gesture recognizer state began. It begins when the two touches have moved enough to be considered a pinch gesture. At that point, the gesture recognizer sends its action message, or messages, at the next cycle of the run loop. Now, it recognizes when the gesture changes with the constant UI gesture recognizer state changed, when a finger moves with both fingers still pressed on the screen. The gesture is recognized as ending with the constant UI gesture recognizer state ended, when both fingers are lifted from the view. The UI rotation gesture recognizer is fairly cool. It looks for rotation gestures involving two touches. So when the user moves the fingers opposite each other in a circular motion, the underlying view should rotate in a corresponding direction and speed. So rotation is also a continuous gesture. It begins when two touches have moved enough to be considered a rotation. The gesture is recognized as changed when a finger moves while the two fingers are down. The gesture is recognized as ending when both fingers have lifted. And at each stage in the gesture recognizer sends its action message. The UI long press gesture recognizer looks for long press or long touch gestures. The user must press one or more fingers on a view for at least a specified period of time for the action message to be sent. Also, the fingers may move only a specified distance for the gesture to be recognized. If they move beyond this limit, the gesture fails. The long press gesture is also continuous. It's recognized as beginning, and the UI gesture recognizer state began constant is set when the number of allowable fingers, which is set by the property number of touches required, when that number of allowable fingers have been pressed for the specified period, which is the property minimum press duration, and also if the touches do not move beyond the allowable range of movement, which is the property allowable movement. Now the gesture recognizer transitions to the change state whenever a finger moves, and it ends setting the UI gesture recognizer state ended constant when any of the fingers are lifted. When one of these objects recognizes a common gesture, or in some cases a change in the gesture, it sends an action message to each designated target object. Now, I strongly suggest that you use the standard gestures in your app as they were designed to be used. Even so, the iPhone's multi-touch hardware and software allow you to go beyond standard gestures when appropriate. Because you can monitor the movement of each finger to detect gestures, you can create your own, but use that capability sparingly, only when it's undoubtedly the right thing to do in your app.